Hello dear students, in this video I'll continue with the problems on boards and streams. I'll continue solving the questions from exercise 3.1 of CBSE Class 12 Applied Mathematics by D Sharma. The speed of a boat in still water is 5 times that of the current. It takes 1.1 hours to row to a point Q from point P downstream. The distance between points P and Q is 13.2 km. How much distance will it cover in 1/5 hours upstream? So here the speed of the boat in still water is 5 times that of the current. So let us take that speed of the boat in still water is x and speed of the current is y. It is given speed of boat in still water is 5 times that of the current. So we have x is equal to 5y. And then it is given we have 2 points P and Q. The distance is 13.2 kilometers. So it takes 1.1 hours to row to the point Q from P downstream. So the downstream time is given and the downstream distance is 13.2 kilometer. The downstream time is given as 1.1 hours. Now we know formula for time is distance by speed. So the downstream time will be distance upon downstream speed. This is equal to 1.1. Or we have the distance is 13.2 upon, here we have x as, it is given the speed of the boat in still water is 5 times that of the current. So x is 5y. So here we have 5y plus y equal to 1.1, or we have 13.2 by 1.1 is 6y. So 6y is 132 by 11, or 6y is 12, or y is 2. Therefore y is equal to 2 km per hour. It is given x is 5 times y. So x will be 5 into 2, 10 km per hour. Now we need to find the distance it will cover in 1/5 hours upstream. So distance covered in 1/5 hours upstream, it will be, we know distance is equal to speed into time. So the upstream speed is x minus y into time is 1/5. 1/5 is 26/5. So we got x as 10 and y as 2. This is 10 minus 2 into 26/5. This is 8 into 26/5. It is nothing but 5.2. So the distance covered in 1/5 hours upstream is 41.6 kilometers. So this is the distance, required distance covered in 1/5 hours upstream. Moving on to the next question. A boat can travel 36 km upstream in 5 hours. If the speed of the stream is 2.4 km per hour, how much time will the boat take to cover a distance of 78 km downstream? So here it is given a boat can travel 36 km upstream in 5 hours. So from this we can find the upstream speed, and speed of the stream is given. So from these two information we can find the speed of the boat. From that we can find the time taken by the boat to cover a distance of 78 km downstream. So let us take, speed of boat is x km per hour. Speed of the stream y, it is given here 2.4 km per hour. The distance it covers upstream is 36 km. So the upstream time T2, it will be d upon upstream speed. And it is given it takes 5 hours to travel upstream 36 km. So from this we get 36 is, I'm sorry, 5 is equal to 36 upon x minus 2.4. So 5x minus 12 equal to 36. 5x is equal to 48, or x is 48 by 5. This is 9.6 km per hour. So we found x as 9.6 km per hour. Now we need to find the time taken to cover 78 km downstream. Time taken to cover 78 km downstream, it will be distance upon the downstream speed. 78 upon x plus y. So it is 78 upon x is 9.6 plus y is 2.4. So this is 78 by 12. So this is equal to 6.5 hours. So time taken to cover 78 km downstream, it is equal to 6.5 hours. Next question. A man can row 40 km upstream and 55 km downstream in 13 hours. Also, he can row 30 km upstream and 44 km downstream in 10 hours. Find the speed of the man in still water and speed of the current. This is a slightly lengthy question. Here it says the time taken to cover 40 km upstream and 55 km downstream is 30. And one more information is 30 km upstream and 45 km downstream. It can be covered in 10 hours. We need to find the speed of man and speed of current. So let us take speed of boat in still water as x and speed of current as y. Now we have the downstream time plus upstream time. In the first case, it is given, let us take this as t1, it is given as 30 hours. Here let us take this as the first case, case 1. So here the downstream time and the upstream time, it is given as 13 hours. We know the formula for time, it is distance by speed. So here it is given a man can row 40 km upstream. So upstream time will be distance upon upstream speed, which is x minus y, and 55 km downstream. So here downstream time will be the distance traveled downstream upon downstream speed, x plus y. So it is 55 upon x plus y. The sum of these two, this is equal to 13. So let us take this as 1. And then we have the next case. Also he can row 30 km upstream and 44 km downstream in 10 hours. So again we have 30 upon x minus y plus 44 upon x plus y. This is equal to 10. So this let us take as equation 2. Now let us take let 1 by x plus y as some variable p and 1 by x minus y as some variable q. So 1 and 2 implies 55p plus 40q equal to 30. Then 44p plus we have 30q equal to 10. So here we have taken 1 by x plus y as p and 1 by x minus y as q. So in place of 1 by x minus x plus y, I am putting p in both these equations and 1 by x minus y, q in both these equations, so that we get these two equations. Now if we solve these two equations, we will be able to find the value of p and q, and then we can find x and y. So let us, third equation, let us solve these two equations. Third equation into 3 minus fourth equation into 4. So this 165p minus, plus 120q minus 176p minus 120q. This is equal to 39 minus 40. So from this we get minus 11p equal to minus 1, or p is equal to 1 by 11. So from 3 we can find q. 55 by 11 plus 40q is 13. So we have 40q is 13 minus 5, which is 8. So from here we get q as 8 by 40, which is 1 by 5. Now let us mark this as A. So A implies 1 by x plus y equal to 1 by 11. From this we get x plus y equal to 11 and 1 by x minus y equal to 1 by 5. From this we get x minus y equal to 5. So if we solve these two, we will get x and y. Therefore, x is equal to 11 plus 5 by 2. It is 16 by 2, which is 8. And y is 11 minus 5 by 2. It is 6 by 2, which is 3. Therefore, x is equal to 8 km per hour and y is equal to 3 km per hour. So this is the speed of boat in still water and this is the speed of current. Moving on to the next question. A boatman takes 2 hours for traveling downstream from a point A to a point B, coming back to point A. If AB equal to 6 km and water flows in the river at 4 km per hour, find the speed of the boatman in still water. So here the time taken to go from A to B and again return to A is given, and the distance AB is also given. The speed of the stream is given. We need to find the speed of the boatman in still water. So let us take the speed of the boat in still water be x km per hour. Then speed of the current y is given as 4 km per hour. Then the distance d, it is 6 km. Then we have the total time, that is the downstream time taken to go downstream plus the time taken to go upstream. It is given as 2 hours. Now we know the formula for the distance travelled. We have d is equal to t into x square minus y square upon 2x. Or we have d is 6, t is 2, x square minus y is 4, so 4 square upon 2x. So this implies, if we cross multiply, we get 6x is equal to x square minus 16, or x square minus 6x minus 16 equal to 0. So here if we have minus 16, the factors are minus 8 and 2. So the roots of this quadratic equation, we have x minus 8 into x plus 2 equal to 0. This is a quadratic equation in x. I am factorizing this x square minus 6x minus 16 as x minus 8 into x plus 2. This is equal to 0. So from this we get x is equal to 8 or x is equal to minus 2. This is not possible. X is equal to minus 2 is not possible because speed cannot be negative. Therefore, x is equal to 8 km per hour. So the speed of the boat in still water is 8 km per hour. Next question. A man can row 3 by 4 of a kilometer against the stream in 11 1 by 4 minutes and returns in 7 1 by 4 minutes. Find the speed of the man in still water. So here the time taken to row upstream for a distance of 3 by 4 kilometer is given, and the time taken to go downstream is also given. We need to find the speed of the man in still water. So let speed of the boat in still water is x and speed of the stream is y. The distance d, it is given as 3 by 4 of a kilometer. So we have upstream speed is equal to distance travelled upstream upon time taken to go upstream. Let us take it as d2. Our upstream speed is x minus y. This is equal to 3 by 4 upon time taken to go against the stream is given as 11 1 by 4 minutes. So 11 1 by 4 minutes, it is 45 by 4 minutes or into 1 by 60 r. So 3 by 4 upon 45 by 4 into 1 by 60. So this is 3 by 4 into 60 upon 45. So this is 15 and 4. So we get x minus y as 4. And then we can also find the downstream speed. Downstream speed, it is equal to the distance travelled downstream upon time taken to go downstream, or we have downstream speed as x plus y. X plus y is distance is again 3 by 4 and the time taken to go downstream is 7.5 minutes. 7.5 is nothing but 15 by 2 into 1 by 60 hours. So it is 3 by 4 upon 15 by 2 into 1 by 60. So we get x plus y as 3 by 4 into 2 by 15 into 60 by 1. So 15 fours are 60. We get x plus y as 6. Let us take this as 1 and this as 2. This is rough. From 1 and 2, x is equal to 6 plus 4 by 2. If we solve 1 and 2, we will get the value of x and y. So x will be 6 plus 4 by 2. It is 10 by 2, which is 5. And y is 6 minus 4 by 2, which is 2 by 2, 1. Therefore, x is equal to 5 km per hour and y is equal to 1 km per hour. We need to find only the speed of man in still water. Therefore, speed of man equal to 5 km per hour in still water. Next question, 17th question. The 17th question and the 14th question are same. In 14th question, there is a typo error, but the data is the same. A man rows to a place 48 km distant and back in 14 hours. He finds that he can row 4 km with the stream in the same time as 3 km against the stream. Find the rate of stream. So here the time taken to travel 48 km upstream and downstream is 14 hours, that is given. And then it is given time taken to row 4 km with the stream and 3 km against the stream is same. We need to find the rate of stream. So let us take speed of boat in still water is x, speed of current is y. In this first case, the first distance d is 48 km. Here the total time, the downstream time plus the upstream time is 14 hours. So the downstream time is nothing but the distance travelled downstream upon speed downstream plus upstream time is the distance travelled upstream upon speed upstream. This is equal to 14. Or here let us take 2 outside. 2 into 24 by x plus y plus 48 plus 24 by x minus y equal to 14. Here it will go 7 times. So we get 24 by x plus y plus 24 by x minus y is equal to 7. Equal to 7. So let us take this as equation 1. And then the next information which is given is time taken for 4 km downstream is equal to time taken for 3 km upstream. So the time taken to go 4 km downstream is given by distance by speed. Here distance is 4 km and the downstream speed is x plus y. This is equal to time taken to go 3 km upstream. Here the distance is 3 km and the upstream speed is x minus y. Now let us take this as equal to 2. Now let us take let 1 by x plus y as p and 1 by x minus y as q. So 1 implies 24p plus 24q equal to 7. Let us take this as 3. And the second equation implies 4p equal to 3q, or we get p as 3 by 4q. Let us take this as 4. Now if we substitute the value of p as 3 by 4q in equation 3, we will be able to find q. So 3 implies 24 into 3 by 4q plus 24q equal to 7. So 18q plus 24q equal to 7, or 42q equal to 7. We get q as 7 by 42. It is 1 by 6. And from equation 4, we get p is equal to 3 by 4 into 1 by 6. It is 1 by 8. Let us take this as a. So from a we have 1 by x plus y equal to 1 by 8, or x plus y equal to 8, and 1 by x minus y equal to, we got q as 1 by 6. So that we can substitute here, equal to 1 by 6, or x minus y equal to 6. Now we can find the speed of stream. Speed of stream is 8 minus 6 by 2. Therefore, rate of stream equal to 8 minus 6 by 2. It is 2 by 2, which is 1 kilometer per hour. So this is the rate of stream. Next question. A man takes 2.2 times as long to row a distance upstream as to row the same distance downstream. If he can row 55 km downstream in 2 hours 30 minutes, what is the speed of boat in still water? So here it is given a man takes 2.2 times long to row upstream than to row downstream, and he can row 55 km downstream in 2 hours 30 minutes. We need to find the speed of the boat in still water. So let us take speed of the boat as x km per hour and speed of the stream as y km per hour. And then let the distance be d kilometer. Then the downstream time, it is given by d upon x plus y. The upstream time t2, it is given by the distance travelled upstream d upon upstream speed, which is x minus y. So we have t2 by t1 is d upon x minus y by d upon x plus y. So it is d by x minus y into x plus y by d. Here it is given the man takes 2.2 times as long to row upstream than to row downstream. So T2 is 2.2 times T1 upon T1. equal to x plus y by x minus y. So we have 2.2x minus 2.2y equal to x plus y, or 1.2x minus 3.2y is equal to 0. Now this, if we divide by 0.4, we get 3x minus 8y equal to 0. And then the next information which is given is, he can row 55 km downstream in 2 hours 30 minutes. So downstream speed, it is given by distance by time. So it is 55 by 2 hours 30 minutes. 2 1 by 2. It is 55 upon 5 by 2, or it is 22. The downstream speed is nothing but x plus y. So x plus y is 22. So we have two equations and two unknowns. When we solve these two equations, we will get x and y. So 1 minus 3 times equation 2 implies 3x minus 8y minus 3x minus 3y equal to minus 66. So here we have minus 11y equal to minus 66, or y is equal to minus 66 by minus 11, which is 6. So from 2 we can find x. X as 22 minus 6. So it is equal to 16. Therefore, speed of boat is 16 km per hour. km per hour. Last question. A boat covers 24 km upstream and 36 km downstream in 6 hours, while it covers 36 km upstream and 24 km downstream in 6.5 hours. Find the speed of boat in still water and speed of stream. So again it is similar question. So let us take speed of boat as x and speed of stream as y. The first case, downstream time plus upstream time, it is given 6 hours. So here 24 by x minus y plus 36 by x plus y is equal to 6. Here we can take 6 outside, 6 upon x plus y plus 4 upon x minus y equal to 6, or we have 6 by x plus y plus 4 by x minus y equal to 1. And then the next case is, it covers 36 km upstream and 24 km downstream in 6.5 hours. Next we have (24 km downstream plus 36 km upstream in 6.5 hours. 6.5 is 13 by 2. So this is 13 by 2. So let us take this as 1 and 2. Now let us take, let 1 by x plus y equal to p and 1 by x minus y equal to q. So 1 and 2 implies 6p plus 4q equal to 1 and 24p plus 36q equal to 13 by 2. So let us solve these two equations to find p and q, and subsequently we can find x and y. So 4 minus equation 3 into 4. we get 24p plus 36q minus 24p minus 16q equal to 13 by 2 minus 4. So 20q, it is equal to, here 13 minus 8 is 5 by 2. So from this we can find q is equal to 5 by 2 into 20, or it is 1 by 8. Then from 3 we can find p. 6p plus 4 by 8 is 1, or we have 6p is 1 minus half, which is half, or p is 1 by 12. Let us take this as A. A implies 1 by x plus y equal to 1 by 12, or x plus y equal to 12, and 1 by x minus y equal to 1 by 8, or x minus y equal to 8. We need to find both x and y. So from this we can find x and y easily. Therefore x is equal to 12 plus 8 by 2, which is 20 by 2, 10. And y is 12 minus 8 by 2, which is 4 by 2, 2. So the speed of the boat in still water is 10 km per hour, and speed of the stream is 2 km per hour. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you like this video, share it with your friends. Thank you for watching.